It is 12:32 according to my clock here, and I can see that the number of participants joining us is starting to slow just a little. So I think we might make a start. My name is Lorraine Van Kerkhoff, and I'm the director of the Institute for Water Futures at the ANU, and I'm very pleased to welcome everybody to our webinar today. I'd like to start by acknowledging the traditional owners of the lands on which we are zooming in from, and pay my respects to elders past, present and emerging. Extend those respects, of course, to any Indigenous people who are joining us today on the webinar. For me, of course, coming from Ngunnawal Ngambri country, but pay my respects also to Indigenous communities and elders from all of the country on which we're coming in from today. It's especially important, of course, to acknowledge country in the context of groundwater, which is our theme for today, as traditional custodians have been managing groundwater on this country for millennia. Time immemorial, I think, is the key phrase here, and it's really a good opportunity, I think, to reflect on the long-term custodianship of our groundwater resources, as well as those that are more visible to us above the surface. I'm really excited to be introducing, well, I'll be passing over to Tony, our moderator today. The Institute for Water Futures, as I mentioned, is an initiative of the ANU, and we have a really important task, I think, ahead of us to bring together the really diverse and wide-ranging skills and expertise and enthusiasm that we have for water and the importance of water and how we can manage it better now, with a view to these increasingly complex and challenging futures that we know are ahead of us. So I'm excited to listen and learn today from our speakers, whom Tony will introduce in a moment. We're relating this, of course, to World Water Day, which was earlier this week, and picking up on their theme of groundwater, to really highlight and explore with all of you the different perspectives and understandings that we can bring to groundwater as such a vital and important resource. So with that, I'm going to hand over to Professor Tony Jakeman, whom I'm sure many of you know, and he's going to lay out the program for today, which is a bit different from our normal seminar program, and introduce our speakers. So over to you, Tony.
Very much, Lorraine. Yes, welcome, please, everybody today. I'm going to just start with giving you a very brief rundown of how this will go. First of all, I'll give a 3 or 4 minute spiel that I think is relevant to World Water Day and this week. Then I'll introduce the speakers, giving you their bios, and they will speak for something like 7 or 8 minutes. That should leave us about 20 minutes for Q&A. So if you could put your questions as they come to mind in the Q&A, I can seek them out there and put them to the panel for the last 20 minutes or so. So we're thinking we'll run for pretty close to an hour. I think that should work well. Let me now just share my screen with you. And it's probably worth mentioning that this function here is part of what we call Water on the Horizons. It was a forum that we introduced last year, and this year we're running it in the Institute right through the year, and this is the first event in that forum. So there will be lots of other events, what we call WAF2, the second one from occurring after last year, going through this year. Okay. I thought it'd be worth bringing out what some of the messages that are being given out for World Water Day on groundwater. And so I might start with saying, well, most of us know that the invisibility of groundwater is part of the problem that's probably had less attention than it's been deserving over the years. But its impact is highly visible, obviously. There are huge problems just with supply, for example, in India, Pakistan, China, the United States, and to a lesser extent, Australia. It's a problem that needs much attention. What we do on the surface, the third point here, matters underground, but the reverse is also true. The director of the National Centre for Groundwater Research and Training, Peter Cook, often shows a little slide where or picture where there's a bore next to a stream and people are pumping it. Well, they're actually pumping stream water, not groundwater. And so the connection between surface water and groundwater is quite important to understand. Measurement is also very important, and groundwater is under measured. It's costly to measure as part of the reason for that. So the use of emerging big data and remote sensing data can obviously help that, but there's obviously no substitute for more measurements of the surface. Importantly, perhaps the last point is that groundwater will play a critical role in adapting to climate change. And my next slide just teases that out a little bit more. If we're looking at adaptation and resilience and climate change, but also other shocks, then groundwater is going to be increasingly important. Adaptations, particularly around conjunctive use, could play a central role. The conjunctive use of surface and groundwater is not really optimized and can be better optimized, not just on farm where people might have surface and groundwater license, but in a system-wide sense as well. Because context is very important, then place-based solutions will be required to do that. And the engagement will be not only with agencies, but with communities as well in those place-based solutions. And of course, we need, from the top too, we'll need reform in institutional policies because current groundwater policy doesn't necessarily lend itself to, I guess, innovations in groundwater management. From the WATH Workshop 1, it emerged that there's the high value of water and data sources and models means that active management of surface and groundwater is really within our reach. But one of the provisos there is that we need to manage any potential disruptive innovation that might occur with innovations in groundwater management. Okay, and I thought as a final thing, I'd just show you a little bright spot on more than on the horizon. It's getting closer. As we know, integrated research, which is sort of user and engagement inspired, is becoming more important and recognised. But the recent report of, it's 2001, I should say, 2021 report by the National Science Foundation US has really brought that to the fore. And so there are certain points that are made there which are quite important if we're looking at solving groundwater problems. So in that sense, then we need to bring together the sciences. And notice that report's putting social up front in terms of the sciences that we need to bring together. And it talks about question framing properly, and it talks about co-production with stakeholders and other interest groups. It talks heavily about engagement and partnerships involving diverse stakeholders at all sorts of scales. And it talks about using our observational, computational and modelling capabilities and talks about not just natural, but social system processes in that modelling. And a key recommendation of that, which I'm sure will follow up with substantial funding in the US, would be that NSF should remove barriers to this so-called convergence research, including facilitating engagement with stakeholders and building transdisciplinary teams. And it's emphasising doing that over the long term, so their project proposals will be longer term and those relationship building activities will be longer term. So that's a little bright spot that's occurring at the moment. So with that little introduction, let me now go to the panellists and give you a little bio from them. I'll just repeat really what you will have seen in the promotion of this event, but all our 4 panellists are doctors from early to mid careers, energetic researchers in various areas that are quite complementary. So our first one will be Joseph Guillaume, the research fellow in the Institute for Water Futures, the Fenner School of Environment, and he's also a DECRA fellow. He's specialised in uncertainty management, in decision support, particular focus on collaborating to construct the future of knowledge management and governance of water resources in Australia. And his presentation will build on the WATH one from last year and the outcomes from that workshop. Second panellist is Wendy Merritt, and she's a research fellow at the ANU and the Institute and the Fenner School as well. And her work focuses on the design and use of integrative methodologies and tools to understand complex socio-environmental challenges. Much of her talk will focus on MAR, Managed Aquifer Recharge, as one of the opportunities available to groundwater management. Third speaker is Mardia Rezegi. She's a research fellow at the AN Institute for Water Futures, but she's in the research field of earth sciences. We have very appointments right across the university. Her work focuses on using geodetic satellite observations to monitor changes in water resources by combining different types of satellite earth observations, such as global positioning systems, gravity recovery and climate experiments, satellite altimetry and soil moisture. She studies total water storage changes and groundwater variation. And that's what she'll talk about today. And we'll have a nice rounding off by Paul Verval. He's in the Institute as well, but in the Crawford School and in the Crawford School of Public Policy. So he works on water economics and policy in Australia and the Asia Pacific. Current research focuses on risk cost benefit analysis of water infrastructure projects and the economics of drinking water provision in regional and remote Australia. Paul will round off this panel presentations by talking about SDG 6, in particular 6.1, which is about by 2030, that's close, achieving universal and equitable access to safe and affordable drinking water for all. So that will be bringing the people element to the fore in that, and what Australia needs to be doing in that respect. So without further ado, I'm now going to pass over to Joseph Guillaume, who will present his presentation. Thank you, Joseph.
Okay, so as Tony introduced, the Water on the Horizon 2020 workshop highlighted the possibility of more active management. So in the context of this panel, what I wanted to do is to sketch out why this might be possible and what could be done over the next 5 to 10 years. So a cornerstone of current policy is obviously long-term extraction limits, and a strength here is that if we've got it in the right ballpark, then there's a good chance that we'll avoid the big impacts of things like subsidence that we've seen elsewhere. But a key issue here is also around variation in space and variation in time. So variation in space at the moment is managed through things like distance thresholds and limits on trade. There's other things that we could be doing as well. In terms of variation in time, we have carryover rules, conjunctive groundwater and surface water use to some extent. We're not really actively managing aquifer recharge. We're not really treating aquifers as reservoirs. And we don't really have a system where when we get better understanding of the groundwater system, we're allowed to add flexibility to how water is used. So when I talk about active management, I'm kind of looking at what are the possibilities that we can do here. So what I want to do first is just to give a little bit of detail about the context we're in. And obviously a key part of this is the sheer variability that we're actually facing. So on the left here, we have the surface water allocations, and on the right, groundwater allocations. And we're obviously also in a context where a lot of our key groundwater resources have seen reductions in extraction limits over time as well. The idea of taking a more local approach isn't new. So for instance, as part of that reduction in groundwater limits, there was a court case that was included discussion of the bandwidth method, where extraction limits or reductions in groundwater extraction would occur based on triggers of water level recovery and drawdown. And so in this case, for instance, the judge was left in no doubt that the minister could have achieved the intended environmental outcome using these kinds of methods if that was desired. Another part of the context here is increasing questions about the role of groundwater. Is it still a bank for drought proofing regions in these changing circumstances? And there's obviously been arguments made previously, for example, here in 2008, about how we can manage groundwater table levels and manage storage and recovery phases and so on to achieve the optimal outcomes that we're after in terms of having groundwater available when it's needed. So now, an important part of the context is obviously recognizing that this is really quite a complex issue. We not only have the local water extraction, but also the spatial aspect of exactly where groundwater dependent ecosystems and assets are, what the dynamics are, and so on. And as Tony had already mentioned, also the connectivity to surface water as part of this. So this is obviously already on the radar of many agencies. So for example, the Statement of Expectations for Managing Groundwater in the MDBA talks about evidence-based triggers to prevent impacts, about localized groundwater level decline risks, and about the need for improved knowledge and adaptation to be incorporated over time. But obviously the focus in this kind of document is on the role of government. And so the question we want to look at is, well, do we have the information in the institutions to be able to account for local variation? And this is in the context of recognizing that, being able to do things at a local scale is expensive, and the transaction costs in policy are very important. States are typically spread rather thin. So why are we saying that there is a possibility? Well, in the Water on the Horizon report, basically what we emphasized there was around the high value of water and the emerging data sources. And part of that disruptive innovation is greater involvement of local communities in achieving these kinds of outcomes. And so I'd like to talk a little bit more about enabling factors. And so we can think here about the fact that irrigation districts not only have these extensive surface water networks, but now typically also have extensive groundwater use and private bores using and able to see what the state of groundwater is as well. A lot of this surface water network is now increasingly automated with telemetry as well. So we not only have unprecedented level of detail about where surface water is at that time, but we can do things like look at leakages and seepage over time. We also increasingly have the capability to look at system level optimization of looking not just at the surface water, but it's not too much of a stretch to think about, well, what is the role of groundwater within this system? How could we actually take that into account in how we deliver surface water to begin with? So what I want to briefly go through here is some ideas around what the near future of groundwater could look like in terms of the next 5 to 10 years. And the first part is the making groundwater visible. I think there's a key role there for building capacity and reducing costs for irrigators to track local groundwater, it not just being a state concern. And obviously part of this is about information sharing agreements, sharing the costs and benefits of new information and rearranging knowledge systems in that way. Part of it is also making regional information locally relevant, where a single agency can provide things for many people. The second part is making current local groundwater use strategies visible, trying to look at, well, what is groundwater's current role and impact in surface water delivery? Are neighbors actually trying to make the aquifer do the same thing, or are they trying to pull it in different directions in how they use their allocations? What local objectives actually need to be met? Will the aquifer actually be able to support us when we need it? And then in managing the transition, thinking about making possible future active management visible, focusing on what capabilities are already useful now, but also around what arrangements are needed for new management to be resilient and robust to shocks in the longer term. How can we ensure that we anticipate disruptive changes so that by the time we get to them, we know what we're doing? And really taking this mind step of one step at a time, what are the first steps on the road to transformative change? So I'll leave it there and pass it on to Wendy.
Thank you, Joseph. I'll just share my screen. Great. Thanks, Joseph. So I'll be giving a quick overview of a case study project that Joseph and I and others were involved in. And this was a collaboration between ANU and University of Sydney to look at managed aquifer recharge from an agricultural context. The project stemmed from the recognition that the talk about managed aquifer recharge has not necessarily translated into a huge amount of action or operationalisation in agricultural settings. So our funder, the Cotton Research Development Corporation, wanted to know whether MAR had potential to support the cotton industry. So basically, is MAR feasible, or should we move on? So we took a case study based approach.
And one of our case studies, the Lower Namoy River, focusing in particular on the area between Narrabri and Weewaw. This is an established irrigation and cotton area. And so really MAR is here looking at ways in which we could optimise an existing capability for operational water management. It's not much, well, no new water around basically. In the Colliambly, the irrigation district that you saw in Joseph's slide, within the Murrumbidgee River system. So again, this is an established irrigation and cotton area. And here we were interested in...
Wendy, if you just share the slide, it's not coming up.
It's the slides, I had shared. Oh, sorry. So yes, in the Colliambly, the Managed Aquifer Recharge, working with the Colliambly Irrigation Limited Cooperative, to look at in-house storage capability of irrigation companies and regions. Our third case study was in the Gilbert River region in far north Queensland. And this is an area, I guess, where there's emerging interest in cotton production. Has a highly monsoonal climate, but with little capacity to actually store water for use when it's actually needed. So here we're interested in whether MAR targeting riverbed sands could actually provide a bit of a storage solution, say for cotton crops to help finish them off at the end of the dry season, or if during the wet season it's a particularly bad year and there's gaps between rainfall that need to be met. So reflecting the uncertainty with innovations like MAR and also the project resources, this was largely a desktop study complemented with some stakeholder engagement. We took an argumentation approach. So starting off with framing, what can we achieve within our project? What scale do we need to try and demonstrate the plausibility of Managed Aquifer Recharge, and who needs to be convinced of its potential? We then moved on to the scenario that looked at identifying how do the non-MAR alternatives that are in place or could be in place, and what are the challenges and opportunities that exist within the system. And the third aspect of the argumentation approach is around the communication. So what level of information do people need? How can we get feedback on the pre-feasibility assessment and the scenarios? And ultimately, at the end of the project, what are the next steps for any MAR innovations that seem to be feasible? And in this project, and linked to the other presentations today, it's recommendations on how to better evaluate local hydrogeology, establish site-specific infrastructure, and the enabling conditions needed to support MAR. So I've just spent a little bit more time on the scenarios and pre-feasibility assessment. The pre-feasibility assessment drew on previous work of Jen Ticehurst and Alan Curtis, which took a holistic approach to looking at MAR innovations. So often a lot of the research focuses on one or so elements of these criteria, so technical feasibility or financial viability. But really, there's a huge amount of uncertainty around these systems, and some of that stems from perhaps social licence and acceptability, the government's arrangements, the demand and availability of water, but also the risks to environment and the like. So we used a number of approaches, heavily relied upon review of existing literature, information on water allocation, use, carryover and entitlement to identify the potential sources of water that could be used and banked via MAR, looked at legislation and policy regarding MAR, and used those to generate scenarios which we could run by through local engagements, by various stakeholders, irrigators, irrigation district councils, NRM bodies, to try and develop these narratives about how managed aquifer recharge could work in these situations. Throughout the project, I don't have much time to get into the detail of these scenarios, but we really identified a broad range of potential motivations for operationalising MAR, which fall into the categories roughly of an economic rationale, a sustainability focus, and that's sustainability in terms of the cotton industry that we're thinking of, or for improved water management capacity. So some examples of an economic focus is calculated improvements to reduce water losses at the farm or irrigation system scale, optimising investment in infrastructure, and maybe turning cheap water into a higher value, more secure water source. Whether or not that has benefits then for cotton is a different story. So in terms of sustainability in relation to the cotton industry, for example, in the Lower Namoy, there have been regional drawdown issues. So could MAR be an option for actually alleviating some of those issues, and more generally in some of the other scenarios, looking at improved systems resilience. And in terms of water management, some of the aspects that Joseph has already touched on, improved control over conjunctive surface water, groundwater use, and developing collective management, active management, and local knowledge of water resource systems into the future. So I guess all the scenarios that were developed for the 3 case studies really relied heavily on the establishment of organisational structures and research and development support that will incrementally improve the local knowledge and water management capacity. Because we did identify in all case studies that there were some pretty critical constraints to MAR. There was still a huge number of uncertainties around how it could actually fit within the existing water management system. So in terms of monitoring, which Maria will talk about or touch on, I guess, with some of the research that she's doing, we still lack, even in the Namoy, which was pretty heavily studied system, enough knowledge at the local to regional scale of the hydrogeology and the groundwater. So if we put water back into the groundwater system, where's it going to go? Are farmers going to actually be able to get their water back? And touching on this is the need for affordable water accounting grade measurement of recharge, particularly if it's going to fit in the current fairly mature water management system in New South Wales and Queensland. So linked with that, there is no specific MAR policy at the moment in the states that our case studies were in. And this means this lack of policy is a substantial constraint to MAR. I guess in New South Wales, there is, with the New South Wales water strategy, there are investigations into what a MAR policy could look like. And then in this context, it's going to be really important to develop policy that plays to the strengths of MAR and manages its risks. What we can do already is invest in pilot studies that is able to be done under the current regulatory system. And it was pretty apparent from all of our 3 case studies that these sorts of pilot projects are needed to build the confidence and expertise and develop this sort of regulatory and farm management understanding of recharge that would be consistent with water accounting requirements that would, I guess, allow the development of robust MAR policy, but also operationalisation and giving people the confidence to invest. So that's where I'm going to finish off just for today. So I'll pass over now to Maria. So thank you.
Thank you, Wendy. I'm going to share my screen. Everyone can see my screen? Okay, as Tony mentioned, I'm going to talk about monitoring groundwater evolution through combining geodetic satellite dataset and in-situ observation. We usually monitor groundwater evolution through groundwater flow models, but these models are limited to the accuracy which the groundwater system has been simulated with. In addition to this challenge, we have other main challenges, like we need information for 100 meters of underground, and in-situ observation are expensive and high maintenance. But what if we involve satellite observation to study groundwater and we look at groundwater from space? The first satellite that I'm going to introduce is Gravity Recovery and Climate Experiment, GRACE. GRACE measures global gravity field changes, which is caused by mass redistribution. We can synthesize GRACE observation, GRACE dataset with other observation and model, and then isolate the groundwater from GRACE total water storage, because GRACE total water storage is showing a combination of soil moisture, surface water, canopy and snow water, and groundwater. Look at this study by Radeb et al. In 2020. They looked at 14 different major aquifers over US. The black time series in these plots are groundwater storage annual variability calculated by GRACE, and the blue one is from in situ. The plot down to each time series is cumulative precipitation anomaly corresponding to each basin. As you can see, in most of aquifers and basins, GRACE is showing a very comparable time series respect to the in-situ observation. However, there are some area that we don't see that much comparability between these two, which can be due to the spatial resolution of GRACE, which is about 300-400 kilometers. Another way to use GRACE for groundwater study is assimilating GRACE into hydrology models, which not only improve the estimation of water storage components like groundwater, but also help us to overcome the spatial resolution challenge and also fill any gaps if there is. This is a study by Tian et al. In 2017. She works here with us at IWF. Is showing the groundwater storage anomaly of Marley-Darling Basin. As you can see, the green and blue time series, which are the assimilated time series assimilation of the GRACE into W3 hydrology model, is showing a very comparable groundwater storage anomaly respect to the observation, groundwater observation. And I also want to mention that now ANU has its own GRACE solution, which has been done by RSCS, Research School of Earth Science, Paul Tregoning and his team. Another satellite is interferometric synthetic aperture radar. This INSAR dataset provides time-dependent surface deformation with a very broad spatial coverage and frequent repeat intervals. People usually use INSAR for monitoring the evolution of time-dependent subsidence, which has been caused by groundwater extraction, and they usually use it for characterizing the ground settlement from groundwater extraction. Look at this study from Miller and Shirzai 2015. They showed horizontal and vertical velocity map. This is velocity of the vertical map, and this is the velocity of horizontal map. And this is the hydraulic head level change. There was a subsidence in this area of Phoenix, Arizona. And as you can see, sub-centimeter of the uplift in vertical map is consistent with tens of meters of observation head level, hydraulic head level change. And then they calculated some aquifer properties using this information and showed that this subsidence is mostly due to groundwater withdrawal. We are currently having lots of collaboration with these people at Virginia Tech. Another satellite, which is the last one, but not the least one, is Global Positioning System, the well-known GPS. GPS drives 3D displacement measurement over the Earth's surface. We can combine this data set with hydraulic head level change to estimate aquifer storage properties. And then through using these aquifer storage properties, we can evaluate groundwater storage volume change over any area. It doesn't matter which spatial resolution, as the GPS is a point-wise observation. This is the work that we have done here at IWF over Lochlan catchment. You can see the Narandara GPS station here with the blue triangle, and these circles are the 3 nearby groundwater wells, about 2 kilometers, 30 kilometers. After doing some correction on the vertical displacement of Narandara GPS station observation, you can see that the residual is perfectly matching with the groundwater level change. Then we can use this information to combine and calculate and estimate aquifer properties and look at the groundwater evolution over the area. This time series is showing groundwater evolution over Upper Lachlan and Bluebell from 96 to mid 2021. This area has experienced 4 different climate events so far, which we catched all of them perfectly. The first one is Millennium Drought, the famous drought, starting from 96 to 2009. And the second one is the La Nina that we had from 2011 and 12, followed by 2 flooding, which this area experienced in 2012 and 2016. And then there was another drought, which was very short, but pretty severe, 2017 to 19, and the La Nina that we're currently in from 2020. So as you can see, the groundwater storage volume change, a spatial map over the area is showing negative volume change for the drought area and positive, pretty positive volume change over the wet area. So through this information, not only we can have aquifer properties and groundwater evolution monitoring, but also later on we're using this information for calibrating the existing groundwater models, which is absolutely useful for a resilient groundwater management. Thanks for listening to me. And now over to you, Paul.
Thank you very much, Mardia, and thank you, Tony, Joseph, and Wendy. Let me just bring up my screen. All right. Good afternoon, everyone. Thank you very much for coming along to our discussion today. I'm going to be speaking to groundwater and sustainable development goal 6 in Australia, which is all about ensuring access to water and sanitation for all. Now, it wouldn't surprise too many people, it would surprise many people rather, who live in remote and regional Australia, that in the 2021 Global Sustainable Development Report, it was reported that Australia had already achieved universal and equitable access to safe and affordable drinking water for all. I've said here that Australia is probably not on track to achieve that target by 2030. And this is one of the key targets under SDG 6 in terms of drinking water, because we don't really know. Unfortunately, in Australia, our national statistics, which we use to track our progress against SDG target 6.1, only includes water utilities with more than 10,000 connections. However, we do know from recent government reviews or government Auditor General reports, such as the ones I have on the screen here, that we do have some very, very serious issues in terms of drinking water provision in Australia, and also in terms of the support structures, in terms of outcomes, and also the lack of monitoring and reporting. We also know as well from lived experience that we have a range of risks and challenges and very serious outcomes which are occurring. So an example of that would be the Barker River in Western New South Wales, and further up on the Barwon River as well, right from Collarenebri down to Menindee, where in 2018-19, we had a real lack of water and a real water emergency in many of these towns. That photo there is from, I think it's Wilcannia or Menindee, I believe, where there was the community organised to truck up bottled water up from Adelaide at their own expense. We also have issues as well, particularly around groundwater, uranium, nitrates in the Northern Territory, Western Australia as well. Trade-offs with commercial water bottling and household bores and access to water, and of course bushfires and floods. And we've seen over the last few weeks boil water alerts all up and down the New South Wales coast. So we have some really big challenges in Australia in terms of access to safe and affordable drinking water for all. Now, I guess the first or the next point of departure that I would make in terms of groundwater is its importance in terms of water security for smaller utilities and for smaller communities and private water supplies. So what I have here on the right is data from the Urban National Performance Report, which is the report that we use in Australia to report against SDG 6. And what it shows, the blue here is the volume of water surfed, the percentage of water sourced from surface water, and then the orange is the volume of water sourced from groundwater. And then for some of those larger cities, we've got some desalination of marine water there. So what do we see? Well, we see for these smaller utilities, 10,000 to 20,000 connections, groundwater plays a really very important role. So that means that when we're managing groundwater, we really need to do so carefully and be very, very aware of some of the risks in terms of drinking water provision. Another observation here as well is that if we look to other small utilities with less than 10,000 connections, groundwater is a key source, and also for private water supplies and some of those smaller remote communities that I mentioned as well, with issues in terms of uranium nitrates and also some of the serious issues in terms of aesthetic water qualities, total dissolved solids and others. Now, this is important because these smaller utilities and communities, these are often very high risk, high cost locations where when there is a problem in terms of the water supplies, there is not necessarily some easy solutions. There are also more likely to be trade-offs with other water uses such as agriculture and mining, and greater exposure to climate, extreme weather events, and in particular, smaller revenue base. So if there are some issues that in terms of broken down infrastructure, it's much more difficult for the local water utility to be able to recoup some of those costs from consumers. My colleagues have taken us through Managed Aquifer Recharge and opportunities in terms of looking for new groundwater sources. I would say that, yes, these do certainly present opportunities for drinking water security, but we do need to think about planned options assessment rather than a more of an emergency crisis approach, which is something that we saw in the recent drought, where the New South Wales government invested a lot of money, not just in emergency water carting, but also in terms of sinking new bores. Now, for many of the towns which benefited from that offset a really serious crisis, but we need to think through these things well in advance and also think about some of the trade-offs with some of the different surface water uses that there might be. So yeah, groundwater sources, Managed Aquifer Recharge is really no substitute for sustainable management of surface water. There are some of the connectivity issues that Tony pointed towards before, and also some of the risks as well. So we don't want to have a situation where we have Managed Aquifer Recharge leading to increased total water extractions, and then that having negative impacts upon the ecosystems and also town drinking water supplies. Another important thing to point out here too, in terms of groundwater, is that we really need to think through carefully the water quality outcomes, some of the costs of treating groundwater, and what the source water quality might be. So as my colleagues know better than I do, and others who are on this call, groundwater is really, really complex. And if we're starting to extract water, we might be stirring up salt or other chemicals and minerals which have been deeper down in the aquifer or in different places. So we need to think about that in terms of health outcomes directly, in terms of health risks and that are in the water, but we also need to think about it in terms of aesthetic water quality. So a good example of this would be the town of Walgett on the Barwon River, which sources its water mainly from the Namoy, but also some of its raw, untreated water from the Barwon River, and then also from bore water as well. But during the drought, really serious water shortages, shift to bore water meant that there was water coming out of the tap, which technically met the health-based guidelines for the Australian Drinking Water Guidelines, but it was extremely salty. Now, what does this mean? Well, it means that if you don't, the taste of the water isn't right, you don't trust it, and you'll be looking to spend money on bottled water, which can be very hard in more remote communities. But also there are health outcomes associated with that if people are drinking more sugary drinks because the water coming out of the tap isn't trusted. And also, although there isn't a health-based guideline for salt content, for particular groups which have to look after salt in their diet, then they can actually bring you up to the threshold of being at risk. So these are some of the things that we really need to think through carefully when we are looking at exploiting new groundwater sources and making sure that the water quality outcomes are acceptable. So I'll just finish off here by highlighting three, I think, important dimensions in terms of visibility of groundwater and achieving or moving towards achieving Sustainable Development Goal 6 in Australia. So the first is that we really need transparent, evidence-based planning. One of the reasons for that is that in Australia, the default is that there's full cost recovery for urban drinking water services. So that means that the default is that consumers will have to pay the costs of infrastructure investment and higher operating costs. Now, recently, the Productivity Commission has recommended that each state and territory should enact a basic level of service, whether that's safety, reliability, affordability, acceptability in terms of aesthetic qualities, and that this would provide a basis for determining subsidies. Now, for those subsidies, we need to make sure that they're sustainable. They're not just for infrastructure, where we have a situation where a reverse osmosis system is put in place in a particular location, and there isn't the training or the wherewithal to be able to operate it on a long-term basis. The second point I would make is that in terms of visibility, we need to think about our policy priorities in terms of water in Australia and as a society. And just as an example, there have been some major investments made in state drinking water government funding programs in recent years. But one program at the federal level since 2017, the National Water Grid Fund, has invested $3 billion in 44 mainly irrigation construction projects. Also, there's some mining as well, which has also included matching state government funding and private funding as well. That's also included $200 million in 73 feasibility studies. And many of you would have heard about the Hells Gate Dam, which had a funding commitment to it earlier this week. And that was also another project which is, although not directly from the Water Grid Fund, has had the business cases funded throughout that process. So I guess the question for my mind, in terms of policy priorities and visibility is are we going to start to see an equivalent long-term federal investments in drinking water infrastructure and operation in Australia? And I would suggest it's something that we probably need to think quite seriously about. And a starting point towards that is investing in monitoring, reporting, and having an understanding about what the needs might be in terms of those types of investments and the policy programs. Now, under the recent Closing the Gap reforms, there have been some targets, community infrastructure targets, which have been highlighted. So that will, we would expect, lead to greater water quality monitoring and reporting. In New South Wales, it's the only place in Australia where water utilities are not required through regulation to report drinking water monitoring testing results, although New South Wales does hold the data, so there is an opportunity there. And across Australia more broadly, it's about 3 million Australians who are excluded from the reporting for SDG target 6.1. Many of those would be reliant on groundwater, and I would suggest that that would be a pretty good place to start to fill in the gaps. Thanks very much.
Thank you, Paul. I think we'll take something, like 10 minutes for questions and have a short summing up by Lorraine, our director. Thank you. There's been substantial comment, particularly in the chat, and a lot of the experts out there, and I mean that sincerely, are actually answering those questions, which is really great to see. Let me just start. One of the first couple of questions are to you, Joseph, which I'm trying to, which are the difference between, which is from Dylan Irvine, I'm just trying to find that one again. What's the difference between active management and adaptive management, where adaptive management is a form of adaptive management? Would you like to
I'd say that when we talk about active management, we're probably usually talking about active adaptive management, but I suppose adaptive management can involve some big changing management rules over time in terms of passive adaptive management. So we're more interested here also in the operational management of groundwater, of actually being able to track within the season or year by year what the groundwater state is, and coordinating and planning activities from that perspective. So it is indeed usually adaptive.
While I've got you, Jason, there's another one about, in terms of all this futures, whose responsibility is it in building that? Where do you see the responsibility lying?
So what we're really interested in here is increasing local engagement and buy-in into the groundwater management process itself as well. And Australia has had various experiments with different levels of consultation and so on. Operational management of groundwater is a new frontier for this. It really allows communities to engage at a level that is meaningful to their own operations, to maximize the value for their local area and so on. And so a key part of this will be about sharing that responsibility, working to what level we can actually devolve certain responsibilities further, and what further policy changes is needed. So that's part of the reason we are talking about this as a potentially disruptive change that needs careful management of the transition.
Wendy, I've got one for you from Sarah Wheeler. Can you see that one? Which is, I'll read it out for everyone. There seems to be no comment regarding the issue that MAR may lead to substantial increases in water use, especially in areas with little regulation and monitoring, such as the Northern Basin. The focus of any evaluation must be broader than just farm level. It has to be a full economic evaluation for the basin as a whole. So,
thanks, Sarah, for that question. And yeah, definitely agree with you. That issue around the potential for increased water use was certainly raised in discussions we had with New South Wales DPI in relation to the New South Wales water strategy and their efforts to develop MAR policy. It's certainly something that they're thinking of and was raised in relation to our Namoy case study, I guess, which fits into the Northern Basin. So yeah, I guess in terms of that's a big reason why in the scenarios that we developed the narratives around how MAR could work, there was such an emphasis on groundwater monitoring and this active management aspect as well. So not just about understanding for the sake of the landholder where the water goes and where they can retrieve it with certainty and security and those sorts of things, but also the downstream impacts and the like as well. So yeah, I didn't touch on that today, and thanks Paul for touching on it in his slides as well. As for the full economic valuation, I agree that that sort of thing, those sorts of analyses would be needed. I think we need these sorts of studies going right from the local and regional scales right through to the catchment. So hopefully that's answered enough.
Okay. And Paul, I've got one for you, which is about infrastructure projects, and there's a lot of uncertainty associated with assessing them. How do you think is a good way to tackle this going forward?
Thanks, Tony. That's a good question. I'm going to give a very obvious answer, and that's we use economics as a first point of call. So thinking about cost-benefit analysis, but also about integrating risk as well. So really thinking through what some of the risks might be in terms of infrastructure projects, wherever things might go wrong, what some of the costs might be, and thinking through all of the different alternatives in terms of making sure we've got adequate, reliable, and safe drinking water. I'd also add as well that it's a matter too of thinking through not just infrastructure, but operations, drinking water quality monitoring, understanding what the source water quality is, and then making sure that decisions are tailored towards the needs rather than one size fits all approach. Thanks, Tony.
Well, got one for you, Marty, or in the Q&A, this one. Apart from field exploration, what are the available methods and tools to assess local groundwater potential? And local, they're thinking of around 5 kilometres square.
Yeah, thanks for this question. Okay, I mentioned GRACE, INSAR, and GPS. GRACE has a spatial resolution of 400 kilometer and monthly temporal gravity measurement. INSAR is a good satellite for covering such area even, but we need to check whether it is covered by SAR satellites or not. But GPS is the most reliable probably for such a scale. We are at IWF the very first people who are using GPS for groundwater study, which there are lots of benefits. One of them is there is no spatial resolution challenge. And even in terms of temporal resolution, it is available always daily. So for such an area, I definitely recommend using GPS.
Thanks, Marty. I think we'll cut it off there in terms of the Q&A and hand back to Lorraine to wrap things up. Thank you.
Thanks, Tony. Thanks, everyone. All the speakers and all of the comments and questions that were coming through in the chat. It was really good to see that there was a lively discussion happening outside that was being stimulated by the presentations. And of course, that's what we're hoping for, and that's what we want to achieve. So thanks to all of our presenters, particularly, but also to our audience who have been engaging as well. That's really been wonderful. I think for me, just as a wrapping up comment in these last couple of minutes, I really, the points that I was getting from this was really trying to see the presentations as a whole and the interconnections between them, because in many respects, even though each of our presenters have taken a different point of departure and are drawing on their own special expertise in relation to groundwater, there are some really interesting patterns and connections across them that I think are worth highlighting. I'm not really talking in terms of the technical matters here, but a lot of what we were listening to today was really based in that idea of understanding. You know, we really need to build a solid understanding of groundwater and surface water groundwater interactions. And from that, start to explore what are the options that we have for management and some of the options that we can start thinking about and working on in collaboration with some of our government agency partners or with farmers, producers who, of course, have such a need to keep moving forward in this really dynamic space. But finally, of course, the options are only good if they're actually going to lead to actions. And I think it's fascinating listening to all of the presentations today to try and think forward to 20, 30, 40 years time, when I can certainly see that groundwater and the active management that Joseph mentioned, the assessment, the risk, our ability to monitor and evaluate in real time, all of this will come together in a real transformation of how we think about and manage our water resources as a whole. So all of this, I think, accumulates to be a really exciting space. And thank you all for sharing. Thank you, Tony, for moderating, to Susan and Erin for all of the coordination behind the scenes to enable this to happen today. And of course, to all of our audience for joining us, listening and participating. So with that, I will close. Please do keep an eye out for our upcoming events via Twitter, via our newsletter, and various other through our website. That's always available to you. Thanks to everybody. And we hope to see you again at our next presentation for Water on the Horizon. Thanks.